Hey, it's Coach Reese. Today we're going to simplify radicals. It's similar, but it's a lot more detailed than what we've done in the past, what you've done in Algebra 1 or geometry. I wish it was just numbers, but today we're going to bring in variables with exponents, and we're also going to do higher powers. It's going to be a little tricky, but I need you to stay with me. Make sure you understand the basics as we build. And then we're gonna do 3 examples together. All right, so let's do some groundwork right here to make sure you understand what I'm going to try to say or the language that I'm going to use. In the past, we have asked you to take the square root of 36. And you said, oh, that's easy. We know the square root of 36. That's going to equal 6. And you're right. But think about the language that we're going to try to apply. We're going to make sure you understand. 36 can be 6 times 6. So we can write this as the square root of 6 squared. Now the reason we want to do this is there is an invisible little 2 sitting right here. It's the square root, but no one ever writes that 2, but there's an invisible little 2 right there. We're going to ask you to divide. We're going to say take the root and divide it into the exponent. And you're going to say that 2 divided into 2 goes 1 time. And that's how we get our 6. Okay? What if we did cube roots? All right, let's say if I give you something that looks like this. And we're going to say I have the cube root of 27. Now we know that 27 is going to be equals a 3 because it is 3 times 3 times 3. So you're going to say, okay, well, we're going to take the cube root of 3 to the 3rd power because there's 1, 2, 3 of them. Remember what I asked you to do, the language that we're going to ask you to do with the process. We said that 2 goes into 2 1 time. We're going to say that 3 divided into 3 goes 1 time. That's how we get the 3. Okay? So when we start using variables, you'll understand the process because the variables that we use are going to have maybe some high exponents on them. For example, what if I ask you to take the square root of x to the 12th power? Now that's a high exponent. What is our root? Our root is a 2. The easy way for you to do this is the process. 2 divided into 2, 3 divided into 3. You're going to say that 2 divided into 12. How many times will 2 go into 12? And hopefully you would tell me that 2 goes into 12 6 times. Now, really, we do not want to have to stretch this out and break this down. We'd like to be able to do a little bit of division. But what this means is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 X's. You don't want to stretch all those out. And then your teacher said, oh yes, and my teacher taught me to look for pairs of 2. There's a pair, 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 there's a pair. Okay, so we've circled all the pairs. And so an X would come out, and an X would come out, and an X would come out, and an X, and another X, and another X, and then you would multiply 1, 2, 3, 4, 5, 6, and you would get X to the 6th. And we've already done 2 more problems by then. So here's the quick way to do this. We're going to take the root and divide it into the exponent, and it'll be the result of X to the 6th. Okay? Now, what happens if your exponent is an odd number or it doesn't go in evenly? All right? What if I gave you a situation that looks like this? Okay? Be careful. We're going to go the cube root. What if I gave you something that looks like the cube root, and we gave you x to the 5th power? What if it does not go evenly? Well, here's what we're going to do. We're going to divide. We're going to say 3 goes into 5. How many times does 3 go into 5? 1 time. So my answer would give me, you just told me, 3 goes into 5 1 time. But you have a remainder of how many? 2. So you're going to take and write your radical. You're going to continue to write your root. And then you're going to write the remainder inside the radical. There's your remainder. 3 goes into 5 1 time with the remainder of 2. Okay, here we go. 1, 2, 3, 4, 5. Here's your group of 3, and x comes out. 2 left over gives you x squared. But again, this is going to take up time. This is going to take up space. Just learn how to divide the root into the exponent. Okay? Got it? All right, good. All right, let's look at the first problem. And before we get on this first problem, I need to teach you one more rule. And this one's going to bother you, but it is a rule. Okay? If we start with an even root, now what does that mean, an even root? Well, even numbers, 2, 4, 6, 8, 10. If we start with an even root, let's say we're going to start with our invisible little 2. We start with an even root. And you end up with an odd exponent. You end up with an odd exponent. So what does that mean? All right, so we have an even root, and we're going to take x to the 10th. Now, we already know what to do. We have just learned that we can just divide. Okay? So we're taking an even root, and we're going to say that 2 goes into 10. How many times will 2 divide into 10? 5 times. So my answer will be x to the 5th. We start with an even root, and my answer is what? An odd exponent. When this happens, the rule says you need to write this in absolute value. Put it inside the absolute value brackets. That's a crazy rule, but it is a rule. Now, you're going to see some teachers that will never ever teach this. But if you want to learn it the correct way, when you have and you take an even root, could be the 4th root or the 6th root, but if you start with an even root and you end up with an odd exponent, you need to write it inside absolute value. Okay? All right, so this is going to happen on number 1. Watch what we do. We're going to break down our 50. Our 50 can be broken down into 2 times 25, and this will be 5 times 5. There's your pair. 5 times 5 is a pair. What are we going to take out? We're going to take out a 5, but the 2 has to stay inside. So this is outside, this is outside. That's going to leave me with a negative 10 on the outside. And we're going to say this 2 was not paired up, not matched up, had to go on the inside. Okay? Now we are taking an even root. Remember what we said. We're going to start with an even root. There is an invisible little 2 sitting right here. We're taking an even root. And look at that. We're going to say that 2 goes into 2. 2 divided into 2 goes 1 time. And that's going to give me n to the 1st power. We start and we're taking the even root, and what did we do? We end up with an odd number for my exponent. We ended up with an odd number for my exponent. So what do we have to do? We have to put that in absolute value. And this would be the correct answer. I told you things were going to be a little bit different than we did in the fall or what you did in Algebra 1 and Geometry. Okay? All right, let's try another problem. All right, so we're going to take the cube root. And yes, we're going to divide by 3, or we're going to look for groups of 3. 256, that's a big number. Okay? Now you can come over here and you can try to do your factor tree with 256, and you can say, okay, that's 2 times 128, 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, and that's 2 times 2. You can do your factor tree old school, but you have access to that Inspire calculator. And we said that we would ask you to do this. We would say menu, number, and we would say factor. And we would put 256 in the parentheses, and we would hit enter, and our calculator would say 2 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 8th power. So we're over here and we're looking at this and we're saying 256 is the same thing as 2 to the 8th power. Uh-oh. We can take the root and divide it into the exponent. Okay. So here we go. 3 goes into 8. 3 divided into 8 goes 2 times. So that's going to leave me with 2 to the 2nd power because it goes 2 times. But what's the remainder? Because the remainder goes inside. If you remember, okay, the remainder goes inside. All right? When we had 3 into 5, the remainder went inside. Okay? So here we are. 3 goes into 8 2 times. The remainder goes inside the radical. Now we look at the other stuff, okay? How many times will 3 go into 4? 3 goes into 4 1 time with 1 left over. Will 3 go into 2? No, 2 is too small. So that just stays inside the radical or underneath the radical. Will 3 go into 1? Because there's an invisible 1 on that z. Will 3 go into 1? No. So that z stays inside. So when we clean this up, because we know what 2 squared is, we would say my final answer is 4, because 2 to the 2nd power is 4, x cube roots of 4x y squared z. This would be our final answer after simplifying that radical. No absolute value. Why? Because we're taking an odd root. The rule was if you're taking an even root and you end up with an odd exponent. Okay? All right, let's try another problem. Look at this. We're taking an odd root. We're taking an odd root, so we do not have to worry about any absolute value. But what we do have to worry about is a negative. Okay? And let me show you something real quick to see if you can catch what we're going to try to do. If we took the cube root of -1. Now that's a scratcher. That's a head scratcher. I'm just going, I'm not sure how to do that, Coach. But look at this, because we're looking for groups of 3. -1 times -1 times -1. This is kind of a special situation. But -1 times -1 is a positive 1. 1 times negative 1 is a negative 1. And look, there is a group of 3. So actually, there's a group of 3. My answer would be negative 1. I could do the same thing with the 5th root. If I said, okay, I want to take the 5th root of negative 1. Okay, negative 1 times negative 1 times negative 1 times negative 1 times negative 1. This, still, when you multiply, is going to equal a negative 1. But we are looking for groups of 5. 1, 2, 3, 4, 5. We're looking for a group of 5. This is going to equal a negative 1. To make a long story short, whenever you take the odd root and a negative sign is involved, you will always bring out a negative 1. No matter what. If we're taking the 3rd root, the 5th root, the 7th root, the 9th root, whatever, if you're taking an odd root of a negative number, no matter what, negative 1 or a negative sign will come out. Okay? So we're looking at this problem. We are taking an odd root. So no matter what, a negative 1, because of that right there, no matter what, a negative 1 is going to come out. So before we even begin, negative 1 times negative 5 is a positive 5. So this is what our problem has turned into now. 5 on the outside, we're looking at the 5th root, and now this is 64 x to the 7th, y squared, z to the 6th. We have already taken care of that negative because it's an odd root. It just automatically comes out. Now let's just handle the problem like we should. We're looking for groups of 5. Let me erase this. So we have the number 64. We put this in our calculator. And we put it in the calculator, and this comes out to be 2 to the 6th power. 64 is 2 to the 6th power. And then you can do a factor tree if you would like. But what does this mean for us? 64 is 2 to the 6th power. So we're going to ask ourselves, look at the root. How many times will 5 divide into 6? One time with 1 left over. So we already have a 5 on the outside. So anything else that comes out will be multiplied. So we have a 5 on the outside. We're going to say that 5 goes into 64 one time. So we're going to bring out a 2 to the 1st power. And we're going to leave in 2 to the 1st power. All right, so just make sure you understand what's going on. 1, 2, 3, 4, 5, 6. Here is a group of 5. A 2 comes out. And when this is out and the 5 is already out, you're going to end up multiplying. Okay? This stays inside. 5 goes into 6 one time. The remainder goes inside. Repeat the process with your exponents on your variables. 5 goes into 7 one time. Let's erase that. I'm sorry. 5 goes into 7 one time with 2 left over. Put your remainder inside. Sorry. 5. Will 5 go into 2? No, 2 is too small, so the y squared will stay inside. 5 goes into 6. We've done this. 5 goes into 6 one time with 1 left over. Now, we're going to multiply because it said multiply. So 5 times 2, my final answer. 5 times 2 is 10. X, Z, and then we have, please don't forget this. You're using the 5th root. Always put your little root in there. 2x squared, y squared, z to the 1st power. There is your final answer when you simplify that radical. Now, I told you it's a little bit different than what you've done in the past. This is going to take some time. You may make some mistakes. If you do, just ask questions, check with us, see if you're doing it right. We'll help you, okay? But don't put this off. Don't just think, it's the same old, same old. It's not the same old, because the roots are higher and now you have exponents on your variables. All right? Give it a shot. Let us know if we can help you. Good luck.